think we can get started now. It's time to go. So thanks to everyone for joining today. My name is Eric. I'm the founder and inventor of Body Rocket. I'm joined today by my co-founder Marcus Honig. We're longtime colleagues from a previous startup, and he is a very successful entrepreneur and has a long track record of spinning out new technologies, particularly in the sporting industry. So welcome, Marcus.
Hello everyone.
So we are experiencing some broadband difficulties this morning. Marcus currently doesn't have his video on. I don't know. He may be experimenting with that when we go to some of the to giving the screen.
Oh, there we are. I'm in.
Okay, there we go. So we also have our CTO. Well, let me unmute him for a second. Our CTO Neil Newell. Self-muted. Okay, Neil, if you wanna unmute and say hi for a moment.
Hi all.
So Neil comes to us with just an incredibly broad background across computers and software and electronics, and has been a real asset to the team as we've been developing the technology. We're going to start by going through our slide deck on the technology side of things, and then I'm going to give a short demo. It's not the demo that I had hoped to give today, but it's still a good demo to show you what we're doing and how the technology works. And then I'll hand that over to Marcus, who's going to get into some of the financials and the business plan a bit more. And at that point, then when that finishes up, we'll answer a few sort of quite frequently asked questions people still have after after they've seen our deck. And then we'll open it up to questions to all of you. So I'm looking forward to doing that. And let me see if I can share my screen here. We'll get started with
Eric. Is it worth, just because I'm not sure everybody's used to GoToWebinar platform, and we even had to figure it out ourselves. So how does it work for people to? Can you explain how it works for people to sort of put a question through? I think they've got a wave, right? Is that correct?
No. And I've actually got a couple different computers open to take a look at. There should be a chat option. Okay. Which I honestly don't see. So I'm in as a panelist on one and presenter on the other, so I don't know for sure, but I believe people will have a chat option, so you can wave.
Can somebody put a question through just to see if it works? If before we start, and we go through this whole thing on the monologue.
Great. Okay. There we go. So Billy's just put a question through. Thanks, Billy. And Stephen. Good. We're all good to go. Okay. Great. Well, let me see if I can share my screen and we'll get going with the presentation. Just get that start. Okay. Great. Okay. Cool. So what Body Rocket is really in the business of is making athletes faster through improving their aerodynamics. Our technology and our patents cover a range of sports, but we're starting with bikes for several reasons. One is that the faster you go, the more important aerodynamics is overall, and bikes move fast. And beyond that, cyclists, especially triathletes, are really tech savvy and already have the mindset to use our data. So our target customer is already logging power and speed, heart rate on their rides in real time, and then they're uploading that to the cloud afterwards and sharing that with their coach or their training software, and probably also uploading it to some sort of a social site so that their friends and enemies can see how much they're riding and out having fun. We focused on aerodynamics for a fairly obvious reason. It is the biggest factor in going faster, and it's also, from a business standpoint, the single biggest unaddressed opportunity in terms of performance gains in the cycling market. So the industry knows this, and they certainly haven't been ignoring it. Aero in the cycling industry is huge. It's the biggest buzzword out there right now. For the last 10 years, the industry has really brought us aero everything. If you go into a store to buy your first bike, you're going to get upsells, and almost every one of those upsells is going to have an aero story to it, whether that's an aero frame or a set of wheels, helmet, clothing, even buying socks and bicycle computers now. There's often an aero upsell story with that. So in terms of the industry and in terms of products, we see the aero problem as being solved. So the question then is what's left, and is it really important? And the answer is, yeah, it's actually huge. It's you, and you are 80% of everything, all the forces that a cyclist is pushing against when trying to go fast. So all of those upsells, all of that fancy equipment is really just scratching the surface versus being able to get your body in the right position and keep it there. Our target market, triathletes and cyclists, are very focused in on this and big spenders on their sports. As an example, triathletes will most triathletes will expect to spend more than $1,000 a year on their equipment, and both demographics are also skewed towards higher education and higher earners. As an example, again, there, the average household income for a triathlete in the UK is above $100,000 a year. So, obvious question, if it's so important, why aren't more cyclists paying attention to it? And the answer to that is just simply, it is hard. It's hard for the athlete. So right now, aerodynamics is a service. You have to travel to a wind tunnel for testing, and you're going to leave with advice that's still typically pretty hard to follow. Your ideal position is likely going to include advice like shrug your shoulders forward slightly or bring your helmet back. And in the next day on your ride already, you're going to have some doubt as to whether you're actually holding that position. You're also going to leave with advice about how you can get in a better position. You're going to get advice on core strengthening and advice on stretches for flexibility so that you can achieve a more aerodynamic position, which then sets up this cyclical needing of this service, which is right now expensive and difficult to get to unless you happen to live next to a wind tunnel. It's also hard for the engineer to be able to directly measure drag in real time. Is not something that's been available or possible with existing force measurement devices that are out there. And so the industry has gone towards a system that estimates as the best way to get that. So professionals in the industry have been going into the wind tunnel for a good 20 years now. For about 15 of those years, there's been at least one device in the market that would give you your aerodynamic feedback in real time on the road. That device and the ones that are coming out more recently all rely on the same principle, same technology, which is commonly referred to as a virtual elevation technique. That relies on taking your power meter numbers and then subtracting energy losses that would come from your drivetrain, from your rolling resistance. It makes assumptions that your body weight stays constant, and then whatever is left over must be the losses from aerodynamics. So we've seen a renewed interest in these devices in the last couple of years. The technology fundamentally hasn't changed, but there's such an awareness of aerodynamics in the market now that we see this really as business people saying there is money here, and if we can, people who can get a device out there are going to be able to profit from that. But ultimately, we think that the devices that are coming to market suffer from these fundamental flaws that I mentioned. We think they've been shown to be very good, and they're excellent as a testing device, which is a step forward from what the market has right now. So certainly still they have some value, but we don't see them ever being able to offer an everyday solution because of the drawbacks that they have. So this is where Body Rocket comes in, and this is where we're doing something different to get around or get away from starting with power. You need to be able to directly measure the aerodynamic drag forces. And this is, I came to this conclusion a lot from my own experiences in the power meter industry back in the early 2000s, when there were only a couple of companies that had direct force power meters, and there were a lot of attempts to be doing estimates and things that could get you that at a much lower cost or more easily. You wouldn't recognize any of those names or remember them because they never really gained much traction. Consumers never really had confidence in them. And I guess we see that same story unfolding right now in this market. At least that's our assessment of the situation. By directly measuring the drag forces, we can take out all those estimates. Our equation, we know everything that's in that equation. There's no guessing there. And the additional upside of that is that then we can take that device into a wind tunnel and directly compare it against the wind tunnel measurements. So what does a device look like? Well, it's 4 parts. It is an integrated stem or aero bar riser, insert between your seat post and your saddle, and then the pedals. And what that does is it isolates you from the bicycle and allows us to look at the horizontal forces, which on a level road are just straight up your drag forces on the athlete themselves. Sorry, just got lost track of my notes here. So it's a common misperception that what needs to be measured for aerodynamics is wind speed. And it's true, you do need to measure the wind speed, but what you want to know is just the wind speed of the undisturbed air that you're going into. And that's measured once at the front of the bike. All the rest of our sensors are looking at how hard your bike is pushing you through the air. And that is your drag force. So again, what that means is if we're looking directly at your drag force, we don't care what road you're on, we don't care what gear you're in, we don't care how much air pressure is in your tires. None of those things are going to affect the accuracy of our readings. And so then the upshot of that then is that you should be able to ride in all conditions and trust your data, and also should allow for research of our device to back that up in a way that isn't currently possible with the devices that are on the market. So then what do you do with this data? That's where this gets fun. So once you've got reliable feedback on your handlebars, then you can use that to go faster. Coefficient of drag times your surface area, or CDA, is the key metric that you're going to get from the device. After a few rides, you're going to know what your CDA is that you can achieve. And when you're not hitting that, you'll be able to move around to find your optimal position. That should help you understand how long you can hold a position before you begin to fatigue or begin to lose power. With our software, you'll be able to look for your optimum position in headwinds versus crosswinds, and have the knowledge to then understand when and how to adjust to the right position to match the conditions that you're in. So this is sort of a comparison of the technologies that are out there today. So a wind tunnel is not real world data. It's not particularly accessible, but it is incredibly precise, very, very fantastic tool for testing. The Garmin Track Aero system, which has been something that a lot of professional teams have moved to, because it is more real that the rider is out there on their bike doing, moving the bike like they would in the real world. It's also often more convenient for the teams to get to. So it's been a good step forward in the market. And then we have a new wave of devices coming out, the Nocho Connect. Garmin is the big player that everyone's sort of waiting for their product to drop. They bought a company 2.5 years ago now, and we're expecting them to release a product. Yeah, they're the type of company that will probably wait until they have confidence. The fact that it's taken them 2.5 years gives an indication of the technical challenges that we think that they're facing right now. And then Body Rocket is the combination of the convenience of these new devices that are coming out with the accuracy and the trustability of the data that you would be getting from a wind tunnel. So bring that all together then, that just means that what you can get with Body Rocket is that real world aerodynamic data. It's not guessing, you can have confidence in it, and that should mean more winning. So I'm gonna move over to, I'm gonna share a screen on my other computer here so you can see the readout. Okay, great. Cool. Okay. So this is the software that's going to be showing the drag forces in our demo. So feel free to drag around the screen so you can home in on the demo or on the data that's being displayed. Just adjust my screen so I can see what I'm showing you. Okay, so, oh, that's right. I was going to give you a little tour of the bike first. So I had hoped to be able to give you a demonstration of our on-bike system today. Unfortunately, I am home alone, and I just haven't been able to figure out a way to do a one-person demonstration of this system and still operate the software and the fan and everything. I tried to order an inflatable dummy that I could at least put on the bike, but I'm sure a lot of you have found this out as well. Amazon Prime now means sometime in the next 30 days or so, and so that's not here yet. So we're going to have to go ahead and go with our older demo, which you'll see in just a second. But I'll give you a quick tour of the test bike. This is the test bike. It's a Trek Speed concept. The rear sensor is integrated into the seat post in this case, and then the front sensor is actually integrated into the Speed Concepts monoriser design on their bike. That's something that we would expect to be doing for the top end bikes with integrated handlebars, is that we will be making an adapter to fit the various designs. Okay, so back over to this. So what's in this box is one of the sensors like you saw on the seat post or the saddle. And this is essentially a miniature floor of a wind tunnel. So we have this section here that's cut out and separate from the rest of the top, and it is anchored to a sensor in here that is looking very precisely at the horizontal forces that are being measured. So anything that's on here, a bike, a car, if you think about this as a miniature wind tunnel, all the forces of the wind blowing on that are going to then be picked up and measured by our sensor. I also have our lovely wind tunnel model, Bob. He's going to be modeling our jacket for testing today, and yeah, demonstrating how we can be looking at the differences in aerodynamic drag. So just give me a second to mount him. Hello. If you were watching the webinar live, you'll recall this is where things started to go terribly wrong. I re-recorded the demo and inserted it in place of the original footage because I don't want everyone else to experience the pain of the frozen screens and choppy audio that we experienced on the day. So picking up where we left off, Bob is now mounted to the body rocket system, and he has a jacket on that he wants to replace. He's been looking at new jackets and reading their marketing claims, and one says it's going to save him 30 watts. Another one says he's going to go a half a kilometer an hour faster. Bob doesn't want to believe those claims. He wants to know for himself. And fortunately, he can because he has a body rocket system. So just to remind you, what we're looking at here is drag forces. And those are forces like anything else. So I can push on Bob, and that's going to register as a force on the system in the same way that we're about to do with aerodynamic drag force. The system of the bike works like this. It's 4 sensors. It is the sum of those 4 sensors that gives us our drag force. So we can do the same thing by turning the fan on and just blowing wind across Bob. So now Bob's out on the road and he's seeing the drag that he creates in his current jacket. He knows what that is. And now he wants to test his new skin tight black jacket. And immediately Bob can see that this jacket is pretty good. Makes a pretty big difference in how quickly he can go. That's logged. He can go out and test the other jackets and see which one performs best for him. Bob can do that across a range of different equipment, helmets, skin suits, shoes, aero bars, but he can also, and more importantly, he can figure out how to put his own body in the right position and keep it there, because that's going to make a bigger difference than any of the equipment that he's looking at buying. And that's the real power of Body Rocket, is helping athletes figure out their own aerodynamics. Body Rocket can help build that picture over time. If Bob had done this test in a wind tunnel, he would come out with a single point for each one of those jackets. But Body Rocket can help you build a much larger picture of your aerodynamics over a range of wind speeds and yaw angles to let you really understand your aerodynamics in the full range of conditions that you ride in, and then help you understand how to best set your bike up for the conditions on the course and the day. At the top levels of the sport, where fractions of a second are important, things like the ordering in a team time trial or just simply getting maximal draft benefit are also key. And that's something where BodyRocket can bring new insight into the market as well. So this is Bob. Let's say he's leading in his team time trial line right now. Most of the time you would think about figuring out ordering for a team trial as ways to maximize the energy savings of the riders behind. But the speed of the train is actually dictated by the guy in the front. So maybe we should be thinking about how to make him faster. It's subtle differences like this. How does the athlete drafting behind affect the speed of the rider in front that we'll be able to start looking at, both from performance level and also from a research level? So that's the new demo. I'll let you get back to the webinar as it was. The other thing that I wanted to talk about was just if you came out of it, if this had been done in a wind tunnel at a consumer level, you would have come out of there with a single point talking about what your coefficient of drag was. But that's not the right way to be looking at aerodynamics for something that's just a collection of bluff bodies like a bicycle is at the speeds that bicycles are going. Your coefficient of drag will change significantly based on the yaw angle of the wind as well as the speed you're going at. And so by using BodyRocket and riding in a range of those conditions, you'll be able to build out that larger picture of what your aerodynamics is, and then be able to make more informed choices off the back of that. Including with the benefit of our software. So our software will be able to, if you have an event this weekend, if you can put the course profile in and the date, we can look up the weather and we can assess what the wind conditions are going to be on the day, know what your normal pacing is, and come back with recommendations about your setup for that specific course, and as well as equipment choices if you have multiple pieces of equipment like helmets, for example, to choose from. Yeah, so I think that's the end of the demo bit. Marcus, I'll throw it over to you, and then I can reset up everything here while you're going through the rest of that presentation.
So thanks for all of that, Eric. It's a pretty exciting time for BodyRocket as we set out to democratize speed essentially. With the introduction of our system, we'll be seeing the cost per hour of speed drop. And that's because we're changing aerodynamics from a service to a product, making aerodynamics available everywhere and anywhere to everyone. So you know, it's a market that is prime at the moment, and with the arrival of a device that can be integrated onto your bike, and being able to measure. Oh, what's just happened here? And being able to measure everything on the go accurately and on the road, we expect the market to change significantly in the coming years. Do you want to move to the next one, Eric?
Yeah.
So as mentioned earlier by Eric, BodyRocket will be the first device that is truly measurable and meaningful. Since we've issued our wind tunnel data results, we have already been approached by Pro Tour teams and professional triathletes. And goes without saying that the upshot to working with athletes at that level will reinforce our position and build the marketing story behind it. Hold on 1 second, I'm just, because my thing is very slow, I'm going to put my video off, guys. Is that better? Is it working? Eric?
I was fine with you already.
Okay, right. And then the fact that the consumer product versus a wind tunnel, which is a service, means that we will now be able to scale this worldwide and make aero drag measurement accessible to all. Okay, so the market is the market is big, but we've taken a pretty conservative approach. Here we take a look at our target audience and market share. If you can, you guys might have seen this before from the documents, but if we sort of look at the pie chart on the left, this is a breakdown of our customer profile by location and sport. We see a majority of our target audience to be triathletes, the two sections in red, where also we know from various market research papers that there's already a 60 to 70% power meter adoption rate, which makes them ideal candidates to BodyRocket. The gray section represents the cyclists in the US and the UK. We believe this is an underrepresentation of our actual potential because this only counts cyclists with a racing license under USA and British Cycling. And then the small worldwide, the white area is essentially an area which we expect to also be looking at for B2B potential and working closely with coaches worldwide. But we'll dive in a little bit. We'll dive deeper into that a little bit later. And then the pie to the right is an illustration to show that we're just targeting a very small percentage of that market in our early years as we position the brand and build up our core following as athletes discover the value of error measurement device. You all right, Eric?
Sorry. You good?
No, are you?
I think you're doing that. How about this?
Sorry?
I think you still have control over it because I didn't do that.
Yeah, so here we're looking at a forecast summary, and you can find this broken down in a little more detail in our business plan and the campaign docs. But just to give you a little bit of a flavor on how this was built, first of all, it's worth noting that these projections are based on the following. One, it's a small percentage of the existing power meter market, and also our knowledge and experience of existing sales channels with existing power meter companies. As you know, Eric worked with one of the leading power meter companies, and we've also been in discussions with quite a few. So really, our projections are based on that sort of knowledge and also on market research that's been done as a whole globally. But to give you a little bit of a flavor, so 2021 is based largely on a Kickstarter campaign, so where we'll be taking pre-orders and expecting to be selling around sort of 100 pieces or so through that channel. 2022 will be our first full year of production and expect sales to be predominantly through our own website, direct to consumer. 2023 onwards, we'll be expanding into new channels such as direct to retail and wholesale distribution channels. And then in 2024, we'll be launching our second tier mid-range version, which will significantly increase our volumes. Eric, next one.
Yeah.
Can you maybe go through the team, Eric?
Yeah. Well, so we already covered this to some extent, but yeah, I'll go a little more into my background. I am a former elite athlete and had represented the U.S. at the 2004 Paralympic Games, where I was a sighted pilot with a four-time Paralympian in Athens. Around the same time, I was finishing my engineering degree and went into the cycling industry for a company called PowerTap, which at the time was one of only two players in the power meter industry, and so got exposed to that technology and also saw the arc of that industry and how it matured, which is very much informing how we're going about what we're doing at Body Rocket. Eventually came to the UK and got a master's in engineering design and moved into a series of startups, the last one being a company called D3O that did impact protection, and that's where I met Marcus and worked with him for quite a while before leaving that to start Body Rocket. So Neil, going to unmute you. I'll do the introduction without you, Neil, and then we can bring you for the questions. But Neil's really a serial inventor and entrepreneur with just a huge background, all the way from being on the special effects team of one of the Superman movies, and it's funny how often that informs some of the decisions we make, all the way through writing online games, founding and selling up a telecoms company, and along the way also being an avid cyclist and record holder of the South Downs Double, which is quite prestigious in the Sussex community. Marcus, I think I went through, well, I didn't entirely go through Marcus's background, but yeah, well, I covered to the extent that is here, but Marcus has commercialized multiple technologies in the sports industry, from motorcycle through team sports, American team sports, and individual sports like cycling as well. Yes, his sporting claim to fame was he placed in the 1997 Hawaii Big Air snowboard competition, which brings me to a little fun bit. We did our first wind tunnel testing. We actually took a snowboard into the wind tunnel simply because it was easier. And I know somebody's asked questions about the pedals. We'll get to that in a minute, but certainly pedals are a challenge, and it was easier for us to take a snowboard in first. So we've actually wind tunnel tested a snowboard as well. Our existing investors, we've got some really great investors on board. Beppo Hilfiger was the president of Cannondale Europe and has moved on to investing in sports tech startups. Some of the names you might recognize are 4Eyes Power Meters and the Stride Running Power Meter. He also sits on the advisory board of Specialized Bicycles, so still very much has his finger on the pulse of the industry. Alex Haper, also a very experienced entrepreneur, with a previous experience outside of the companies that he has run in innovation management as well. So really great guidance and advice that we get from both of them. Hand it back over to you, Marcus. Have we lost you, Marcus?
No, sorry, I just realized I was on mute. All of these buttons to push is making it very difficult. Yeah, cool. Thanks, Eric. So yeah, this is really just a kind of, as we're sort of putting ourselves onto CrowdCube, we want to give you a little bit of background onto what we've done to date. Certainly from an investment point of view and how we got to where we are today. So we're currently in phase 3 of our development, essentially our sort of development phase was split into 3 sort of stages, call it. Phase 1, which was really the design and the development of the core sensing technology. Phase 2 was the validation of our system in a wind tunnel. And now we're entering into phase 3 of our development, which will take us to MVP, meaning we can also offer services to professional teams and athletes and have first revenue streams by the end of the year. You've also got here just a sort of snapshot of what we've raised in the previous rounds. So it gives you a little bit of an indication of where we stand as a business.
Sure. Okay. If I can ask you to just kind of breeze through this, we're pretty far into this and haven't opened up the questions yet, so I'm keen to get there if you can, Marcus.
So should we just go a bit quicker then, yeah?
Yep.
Okay, we can maybe go through that in the questions, but essentially we'll be introducing multiple sales channels as part of our growth strategy, quite carefully phased as we build up momentum and credibility with our audience. It's also position the brand. There'll be few aspects within that. There'll be the services aspect where we will be continuing to engage with our clients, use that to kind of learn, listen, explore, and always be part of our sort of relationship with our audience and the product. Then from a product perspective, initially we'll be launching direct to consumer through our website, and then slowly phasing into direct to retailer for sort of specialist retails, wholesale distributors as we introduce the mid-range offering as well. And finally, whilst this is not something that's been sort of put into our sort of numbers, the product will come with a basic level of data analysis similar to that what you would expect to get from a wind tunnel test, but deeper analysis will be available through a subscription service for those that want to maximize their aero gains. We're still sort of trying to figure that one out, discussing with people what the best model would be, but it's just more as an FYI that we do expect to go down the sort of subscription based model at some point in the future. Eric, right. Move on.
Okay. Yep.
Well, how far in? Yeah, we're about 40 minutes in, aren't we? Do we want to open up to questions, because this is really summaries of the last 2 slides are really summaries. So they'll probably be covered in most of them.
Cool. Okay. Yep. So this is all available for everyone who's signed up on CrowdCube. They can request these documents. This is there. So yeah, let's skip on to questions. I am going to just bring Neil into this if I can. Okay. Yep. Okay. So Neil, you've got permission to talk whenever you want to unmute your microphone. So let's see here. I'll start just in chronological order here, and skim through a few of these quite quickly. Rob asks if the sensor in the demo was the same as the sensor on the bike. It is literally the same as the sensor on the bike. It's just in a different case. So yes. Guido called me out for using grams as a unit of force. Apologies for that, Guido. It had to do partly with talking to non-technical people in our investment, and also just the magnitude of the forces are such that if you do it in newtons, it looks meaningless. So so we just made the decision to be doing that in grams. Alex asks a technical question. He says, it seems quite straightforward for me to measure the force in the seat post and the saddle or in the handlebars. What about the crankset? And yes, absolutely, that is the most challenging place. And that has been the focus of a lot of our development going into the wind tunnel testing. And there's additional development that is still required there. If you see the pictures of us in the wind tunnel, we actually have some large discs on the pedal still. So we're using an external reference source for the angles as a backup, because we didn't want to lose all of our wind tunnel data in the event that things weren't working. So yeah, there's some work that's going on there. In fact, we are bringing on a quite experienced another power meter engineer, someone who's been in the power meter industry a little more recently than I have, in this next stage. And it's part of what this funding is for, to ensure that we knock that problem on the head and have a quality product there. But yeah, pedals were a very difficult thing for the industry to develop. There's a lot of background experience there now, and we're pretty comfortable we've got that under control. How easily can the sensors be attached to a current bike, or does it require a new integrated seat post and stem? So on the seat post, you will just take your saddle off and you will clamp our sensor onto the top of your seat post, and then you'll clamp your saddle onto the top of our sensor. So it just fits in line. Most bikes still do come with a stock stem, and so you will swap that out. Although certainly our early adopters are all going to be on the kind of bikes that have integrated handlebars now. And for time trial bikes, we'll have an adapter for all the main brands, so that you can put our sensor on in place of your existing elbow risers. So what that leaves out right now is integrated handlebars on high-end road bikes, and so that's something that we need to address in the future. But right now, that would be the type of bike that we wouldn't fit onto. Is the equipment allowed within Federation rules? Yeah, there's nothing in the design of our equipment that falls outside the rules for existing stems, seat post, or pedals. And as it's a new product, nobody's really weighed in on whether you can have aerodynamic measurement on the bike or not. Weight and drag force is measured by the seat post. Yes, all the sensors are actually measuring the drag force and the weight. So we're looking at a bunch of metrics. We're looking at your position on the seat and the handlebars as well. So we can break down when you've moved from one position on your bike to another based on some of the other metrics that we're looking at. Drag force is of course the key one, but as soon as you start going up and down hills, then weight becomes important as well. In fact, one of the ways to show how good the competitive method can be is to go out with an empty water bottle and a full water bottle and show the difference in those measurements. Unfortunately, that means that you can't sweat or drink a water bottle and expect that system is going to continue working at the same level of accuracy. So by us constantly measuring the weight as you onboard food or water or become dehydrated or get soaked in a rain shower, we'll just simply know what you weigh now, and that will be part of the equation. Oh boy, that question's so big, I can't even fit it on the page. Well, hello, Dan Bigham. Thanks for joining today. How do you plan to deal with calibration across a wide range of integrated superbikes? So the calibration is really in the sensors themselves. It's the same as you would get with a power meter. So when you buy a power meter, it comes calibrated. When you put it on your bike and you roll out for a ride, you're going to need to do the same thing. You're going to need to hit a button and wait for a couple seconds while we zero the sensors. But that is done in the factory before you get them. Yeah, pedals are an issue, and so right now we are going forward with the pedal option. We will be forced to choose between brands of pedals, and that is that's actually currently how our projections are put forward is that we say we're going to have to choose a pedal, and that's going to sort of limit us to a third of the market. Most people are going with a look pedal for power meter pedals right now. That decision is still out there to be made. We are also still actively looking at cranks as an option, because that would bring that would open it up to everyone again. There's some sensing challenges around cranks. It makes it easier for us to do it with the pedal, but we realize that there's reason to carry on with the cranks, so we'll keep doing that. So I think I answered your question about longitudinal and drag force. I guess I didn't mention that we're monitoring inclination in there as well, but we have the weight and monitoring inclination. And interaction effects, yeah, those are part of the paper that we're still in the process of writing.
Can you say the question out loud, because I don't think other people are reading the question. So if you're just answering them, then people probably don't know what you're answering.
Yeah, do I need to go back there? I guess pedals were probably pretty obvious. The question about longitudinal forces, so Dan had asked about how we monitor longitudinal forces and we take out things that are not drag, and that is because we're looking at your body weight and we're looking at inclination. And then finally, interaction effects between the rider and the bike, and that's something that is going to be inherent to the system, and we've begun to look at that in the paper. We don't see that being a large component, and the indication from our first test results is that is not a large component, but there needs to be a lot more research there. This is a new device, and so we are looking to work with several different research facilities at universities to do ongoing testing and broaden the knowledge of our system. So Peter asks, is BR easily transferred between bikes in the same way that some power meters are? You'll have to swap out your stem and put an insert in your seat post, and then swap your pedals over. So it can be done, but I wouldn't say that it is. It's something that you would want to frequently swap between your bikes. Marcus, if I can hand a question over to you. Rupert asks about retail price.
Yeah. So at this stage, obviously we're still in development. There's certain things that we're sort of working on and still trying to figure out. But essentially, we're expecting to sort of launch into the market in the same way as power meters have historically. We're expecting our sort of first device to come in the region of about $14.99 to $18.99. And then expecting to bring that down to sort of sub £1,000 moving forward as we introduce the sort of mid-range entry-level one.
Cool. Okay. I think we've overrun a bit, so I'm just going to do two more questions. One is from Giannis, and he's asked, what is the metric we are getting into Garmin? Is it CDA? And will there be any integration with current power analysis tools like WKO and Golden Cheetah? So in terms of the metric, yes, CDA will be one of the metrics. We expect to also be telling you your wind speed and yaw angle, because with that information, you will be able to, and the knowledge that you gain about your aerodynamics, you'll be able to adjust to the conditions. In terms of integration into the existing ones, it's not clear how that would work yet, in that this isn't, there's a step where you definitely want to be looking at your aerodynamics and your power output and making that into a metric that you're monitoring. There needs to be some research there. I'm not aware, at least, of an equation that allows you to do that yet. So there's going to be some research behind that at that point. It's the right time to start talking to those platforms. Golden Cheetah obviously has a lot of interest and a lot of enthusiasts in the aerodynamic world. And so I would expect that that's probably a very likely place to start and for us to start to put some tools in. But I do think that we'll have our own analysis software as part of this for the deeper analysis as well. So one last question from Carlos Marcus. Can you go into the exit strategy?
Yeah. Well, actually, since you kind of have the slide.
I do. Is that still up? It is. Yeah.
Sorry.
Yeah, that's still up.
Yeah. Hold on, just 1 second. Oh God. Can't really. How do I put the? Trying to figure out how to put the picture. Right, so exit strategy, yeah. So what we, the way, I mean, obviously, it's all of this is always about timing and how, you know, and introducing the technology at the right time. Right now, we do feel like this is a really hot topic of discussion. So you know, the timing certainly is right. The market, there's the demand behind it. We do expect sort of a trade sale initially as we launch into the cycling product from one of the sort of cycling component companies such as Shimano or SRAM or Garmin, with an expected sort of exit around sort of 15 to 20 million. Eric might be able to sort of share a little bit more detail on that, but that's kind of the way that we see it over the next sort of 3 to 5 years. One thing that we haven't really touched on here is that whilst we're talking about cycling, the cycling market, our IP and also our knowledge of some of the other sports, you know, we can see the technology being applied into new verticals within the sports industry. One good example would be within the ski market, where we expect the size of the market is fairly similar to the cycling segment. And then at that point, that would mean that, you know, we wouldn't be looking at a sort of cycling component trade deal, but more on the sports conglomerate. I'm not sure if you guys are aware, but there's companies such as Amma Sports, which own various sports brands such as Mavic, Salomon, and so on. So there, you know, at that point, if we introduce the new technology, and whether we do that by way of licensing or launching the product directly, we would expect an exit closer to the 50 million mark.
Great, thanks, Marcus. So appreciate everyone who stayed on. Sorry we ran over, and sorry the demo didn't quite turn out as planned. Sort of at the mercy of broadband today. So yeah, thanks again. And if you have any follow-up questions, I don't know if there's a way to do this. We will post, I think I have a way to email everyone afterwards, and I will post a link to this video afterwards. And then when I do that, you should have my email address if you don't already, and feel free to ask me any more questions. So thanks again.
Thank you.
Okay. Bye-bye.
Thanks.